Hello and welcome to 5th grade math. I'm Mr. Manella and joining me as he always does is my assistant, Stu. How you doing today, Stu?
Well, I have some regrets about that entire bag of family-sized Takis and that huge iced coffee.
Yeah, well, that's how we learn things in life, okay?
Oh, yeah.
Sometimes we do things we shouldn't do,
Ugh.
and we learn not to do them again.
That was so spicy.
Yeah, you were.
Anyway.
But, yeah, speaking of learning things, okay, today we're going to be learning about how we move our decimal point, okay, and when we multiply by a power of 10.
Decimal points can move.
They sure can.
They don't have legs.
You don't have legs and you move.
Are you calling me a decimal point?
No, you look much more like a question mark.
Hey.
All right, so moving your decimal point, when we multiply, we get bigger. So now we need to figure out which way our decimal point is going to move.
Okay.
Let's take a look.
Which way?
Okay, let's look at these two prices. They both have the same digits, but are they equal?
No. $2.50 is more.
It is. So which way did my decimal go to make 25 cents into $2.50? It was on the left of the two, and now it's on the right. So it moved to the right. Hey, 25 cents is a quarter, right? How many quarters do you need to make 250?
Well, I know there are 4 quarters in a dollar, so that means you need 8 quarters for $2 and then 2 more quarters for that 50 cents. So 8 plus 2 is 10. You need 10 quarters.
That's right. We multiplied 25 cents by 10 to get to 250. And all we had to do was move a decimal like this, okay? So there's your 25 cents, and then you move your decimal over one spot to the right. And now, since we don't need the 0 holding a place in the ones place anymore because the 2 is there, we get rid of it. But we do need a 0 because this is money to come after the 5 in the hundredths place, and we put it there. Okay, so all we had to do was move a decimal, and adding a 0 at the end of a decimal doesn't change the value. So when we multiplied, which way did the decimal move?
To the right, to the right, to the right.
Thank you for that. It is correct and rhythmic, and I appreciate it.
Yes.
So remember how the number of places in the previous videos told us how much we were multiplying or dividing by because it was the same as the number of zeros in the power of 10?
Yeah, I remember.
Well, this time the power of 10 that we're multiplying by tells us how many places to move our decimal point to the right. Let's look at the whiteboard. Here it is, okay? There's my decimal on the whiteboard. 3 and 745 thousandths, okay? Let's say I have this number, 3.745, and I want to multiply it by 100. What do I do? Did you just squeak at me?
Maybe.
Why did you squeak at me?
Sometimes I squeak when I'm unsure.
Okay, well that's good to know. You should definitely not play poker though, because if you squeak when you play poker, people are gonna know. They're gonna call that a tell. Yeah.
I got a couple of those.
Well, I mean, you don't have any money anyway, so you shouldn't be gambling.
Oh, yeah.
But if you play for fun, even then, try not to squeak.
Okay.
Okay, we got a little sidetrack there, but
Yeah, you were asking me how to multiply this by 100, and I don't know.
okay. So what direction are we gonna move the decimal?
To the right.
Good. And when we multiply by 10, how many places did we move it?
1.
Okay. And how many zeros does 10 have?
1.
And how many zeros does 100 have?
2.
Okay, so 1 0, 1 place. 2 zeros.
Oh, 2 places!
Yes! The number of zeros tells us how many places to move our decimal. The number of zeros in the power of 10 that we're multiplying by, of course. If you multiply this number by 7, you're not sliding the decimal. It only works with powers of 10. Watch! Here's my decimal.
Okay. Watching.
1 place.
Yeah.
2 places. And don't forget to put
Yeah.
your decimal in the new place and erase the old one, because if you don't actually move the decimal, then you don't actually do any multiplying. You gotta actually move the decimal.
Yeah,
There.
man.
So now it's 374.5, or
Oh.
and 5/10, or it's also 1/2. We'll learn more.
Oh.
We'll learn more about that later.
Whoa.
Yeah.
Yeah.
Decimals and fractions, they're the same.
Multiply by 100, move the decimal 2 spaces.
Exactly.
Yeah. Miss Murnau.
Yes. Yes. What is it?
Murnau.
But yes.
Uh, How many places would you move the decimal if you multiplied by 1 million?
Well, how many zeros does 1 million have?
6.
Yeah. So you move it 6 places.
But Mr. Manella.
What?
That whiteboard.
Oh, you want the whiteboard?
Get the whiteboard. Yeah.
All right. What is it?
Look.
What?
That number doesn't have 6 places. How can I move 6 places when it doesn't have 6 places?
Oh man, you're totally right. But we can fix that. Okay, watch. You're still gonna move your decimal 6 places. You're still gonna make 6 loops.
Yeah.
Yeah, you're just gonna have to use a little bit of imagination. Okay. So 1, 2, 3. We're gonna make 4, 5, 6. Okay, and then. Okay, we made it 6 loops, right? But we need to fill in those places.
Yeah, there's nothing there.
Well, thankfully, there is a number in math that we can use as a placeholder to fill in empty places because it has no value. And it won't change the value of a number.
I know it.
What is it? What is it?
0!
Zeros!
Yeah.
1, 2, 3. Then we add a couple commas. That's not a decimal anymore. Now it's a comma. Okay? Do you want to take a stab at naming this number?
That's the thousands comma. And that's the millions comma. 3,745,000.
That is correct. If you are multiplying by a power of 10, that is so big that it forces your decimal to go past any digit still in the number. That's fine. You just keep making the necessary loops like we did here. I erased them to make the number look a little bit cleaner, but you can imagine that they're there. You can still see the end of it. You just make the loops that you need to make and fill it in with
0.
Oh, man, you just breathed right in my face. But you're right, so I'm going to let it slide, okay?
Thanks.
Yeah. All right. So, need extra spaces, loops, and zeros. You can definitely do it.
All right. Yeah.
All right.
Mr. Manella.
Yes.
I'm so full of questions today.
That's great. That's how you learn.
So when we were talking about moving that over and you put zeros in, and you said 0 had no value.
Yeah.
But before we talked about how value changes when you multiply by powers of 10.
Yeah.
I'm just confused about the value of those zeros. Okay,
that's an excellent question. Let's clarify that, okay? Because here, right, we put some zeros at the end. We did 3.745 or 3 and 745 thousandths times 1 million, okay? And we ended up moving our decimal 6 places because we multiplied by 1 million. And that is a massive change in value. So when I said 0 itself doesn't have any value, that's true. The number 0 doesn't have any value. But when 0 occupies a place, each place at the end is worth a power of 10. And those places have value. So when we put 3 extra zeros in, that gave us extra place value. So you can see here now that this 3 was in the ones place, but now it's in the millions place, which is a massive value change. And we wouldn't have been able to change those values without moving our decimal and putting zeros in. So even though the 0 itself, no value, when it occupies a place in a number, it gives the number more value.
Yeah, it's that whole thing, place value.
Exactly. Place value.
Oh. I get it now.
Awesome.
Thank you.
You're welcome.
Yeah.
So, to recap, when you multiply a decimal by a power of 10, all you need to do is move your decimal to the right, and the number of zeros in the powers of 10 tells you how many places you need to move your decimal. And if you run out of places, you keep moving your decimal, you keep making your loops, you put your decimal where it belongs, and then you fill in those loops with
0, my hero.
That's right. It is a pretty heroic number because it does all kinds of magical things. We might
Mathemagical.
Mathemagical. That is a brilliant term that you just invented right now. And if anybody else tries to take credit for it, we're going to hire some lawyers.
Yeah, lawyers.
We're not going to do that.
No, they're expensive.
They are.
I probably didn't invent it.
Probably not. But it's still pretty cool.
It's still mathemagical.
It is. Okay? This concludes our video lesson. See you next time.
Bye.
Bye.